Hello Year 11 Mathematics Advanced students. Today we're continuing on with the topic of functions and we're learning about the discriminant. So the solutions of an equation are also called the roots of an equation. So let's solve x squared plus 10x plus 24 equals 0. So if we were to solve this, we would write that we have a product of 1 times 24, which is 24, a sum of 10, and we need factors of 24 that add to 10. So what we're going to use in this case, we need them both to be positive, so we need two positive numbers that add to 10. So we have 4 and 6 as factors of 24 that add to 10. So we can then put these in brackets, so we'll have x plus 4, x plus 6 equals 0. So therefore we have x plus 4 equals 0, and we have x plus 6 equals 0. So to find out what x is equal to, we would for x plus 4 equals 0, we would subtract 4 from both sides, and for x plus 6 equals 0, we would subtract 6 from both sides. So therefore we get the values of x being 4, or minus 4, sorry, and the other value of x to be negative 6. Now these are our roots of our equation, and we have two roots. So we go, therefore, we have two roots. We have x equals minus 4 and x equals minus 6 as our roots. So in the quadratic formula, x equals minus b plus or minus the square root of b squared minus 4ac over 2a, we have the expression of triangle, which means the discriminant equals b squared minus 4ac, which is called the discriminant. So we have that these are equal to each other. So the discriminant gives us information about the roots of the quadratic equation ax squared plus bx plus c equals 0, where our discriminant is represented by the triangle equals b squared minus 4ac. So let's have a look at some examples. We want to use the quadratic formula to find how many real roots each equation has. So our first equation, we have x squared plus 5x minus 3 equals 0. Where from solving quadratic equations, we know we need to label what a is. So a is 1, b is 5, and c is negative 3. So then we want to substitute these values into our quadratic equation, which we can see above. So this equation here, so we'll have our x equals our minus b, so minus 5, plus or minus the square root of our 5 squared, which is our b, minus 4 times our a of 1, times our c of minus 3, all over 2a, so 2 times 1. So when we substitute that in, or solve that, we have x equals minus 5, plus or minus the square root of 5 squared minus 4, or 5 squared is 25, and then minus 4 times 1 times minus 3 is plus 12, all over 2 times 1, which is just 2. So this is minus 5 plus or minus the square root of 37 over 2, and we can't simplify this any further. So therefore, our x equals minus 5 plus root 37 over 2, and minus 5 minus root 37 over 2. So therefore, you can see that we have two real roots in our equation, because we were asked to use the quadratic formula to find out how many real roots each equation has, and so we have two real roots, so two roots are given to us. For the next equation, we have x squared minus x plus 4, so we have a equals 1, b equals minus 1, and c equals 4. So we have our x equals our minus b, so minus 1, plus or minus the square root, minus 1 squared, minus 4 times our a of 1, times our c of 4, all over 2 times a, which is 1. So this equals minus 1 times, or minus times minus 1 is just 1, plus or minus the square root of minus 1 squared is just 1, and then 4 times 1 times 4 is minus 16 over 2 times 1, which is just 2, which equals 1 plus or minus the square root of negative 15 over 2. And hopefully you're going, we can't do that, because whenever we have a negative in a square root, we don't get an answer. At the moment, there is no solution. So we write, therefore, there are no real roots since root negative 15, or the square root of negative 15, has no real value. So to answer the question of use the quadratic formula to find how many real roots the equation has, this equation has no real roots because the square root of negative 15 gives us a math error on our calculator and there's no solution for it. For C, we want to find how many real roots the equation x squared minus 2x plus 1 has. So we write A equals 1, our B equals negative 2, and our C equals 1. So we have x equals our minus B, so of minus 2, plus or minus the square root of our B squared, so minus 2 squared, minus 4 times our A of 1 times our C of 1, all over our 2 of A, which is 1. So this equals minus times negative 2 is 2, plus or minus the square root of negative 2 squared is 4, minus 4 times 1 is 4, all over 2 times 1, which is 2, which equals 2 plus or minus the square root of 4 minus 4 is root 0, all over 2. So our x will just equal 2 plus or minus root 0, which is just 0. So it equals 2 over 2, which equals 1. So therefore, we are only given one real root. We just have that x equals 1. So there is one equal root. So instead of having equal real root. So because we have only one value, it works for any value of x, and there's only one of them, and so we call it an equal root because the positive and the negative version has 1. So now we have the discriminant, and we're going to talk about this a little bit more. So the value of the discriminant is our triangle equals b squared minus 4ac. Tells us more information about the roots of the quadratic equation, ax squared plus bx plus c equals 0. So whenever we see this triangle in maths, it means the discriminant. So when the discriminant is greater than 0, there are two real roots. So if the discriminant is a perfect square, then the roots are rational. So that's where a perfect square is any number that can be square rooted. So we'd have 4 is a perfect square because the square root of 4 is 2. 9 is a perfect square because the square root of 9 is 3, etc. Or if the discriminant is not a perfect square, then the roots are irrational. So if it's not a perfect square, it just means it's a number that can't be square rooted to a whole number. So such as the square root of 15 does not equal a whole number. So it means that if we had our answer of 15, it would be irrational. When our discriminant equals 0, then we have two equal roots like we saw in that last example, or one rational root. So that means that we just have one answer, but it's equal for all. And when the discriminant is less than 0, it means we have no real roots. Okay, so the roots aren't real and it would look like b. So having a negative in the square root would be that case. So what we want to do for our example now is show that the equation 2x squared plus x plus 4 equals 0 has no real roots. So what we do, just like a quadratic equation, we say that our a equals 2, our b equals 1, and our c equals 4. And we substitute these into our discriminant. So our discriminant equals b squared minus 4ac. So our discriminant equals b squared, which is 1 squared, minus 4 times our a of 2, times our c of 4. So we get our discriminant equals 1 minus 4 times 2, which is 32. So we get our discriminant equals minus 31. So our discriminant is less than 0. So because our discriminant is less than 0, it means therefore we have no real roots. And we've shown that. Moving on to example 3. We want to describe the roots of the equation 2x squared minus 7x minus 1 equals 0. So again, off to the side, we write what our a equals. So our a equals 2, our b equals negative 7, and our c equals negative 1. And we substitute these into our discriminant, which equals b squared minus 4ac. So our discriminant equals b squared, so negative 7 squared minus 4 times our a of 2 times our c of negative 1. So our discriminant equals negative 7 squared is 49, minus 4 times 2 times negative 1 is plus 8. So our discriminant equals 57. So because our discriminant equals 57, our discriminant is greater than 0. So therefore we have 2 real. Now because we have 2 real roots, we need to state whether it's rational or irrational. So this one is irrational because we cannot square root 57 and get a whole number. If we could square root 57 and get a whole number, then that would be okay. 3b, we have that x squared plus 6x plus 9 equals 0. So our a is 1, our b is 6, and our c equals 9. So we're going to sub these into our discriminant of b squared minus 4ac. So our discriminant equals 6 squared minus 4 times 1 times 9. So our discriminant equals 36 minus 36. So our discriminant equals 0. So when we have our discriminant equals 0, it means therefore we have 2 real equal. And because we can square root 0 and get a whole number, we have 2 real equal rational roots. For example 4, we want to find the value of k for which the quadratic equation 5x squared minus 2x plus k equals 0 has real roots. So what we're going to do is that for when we want real roots, what do we want our discriminant to equal? So when we want real roots, we want our discriminant to be greater than or equal to 0. So therefore, b squared minus 4ac is going to be greater than or equal to 0. So now let's state what our a, b, and c are. So our a equals 5, our b equals negative 2, and in this case our c equals k, and that's what we're trying to find. So let's substitute them in. So we have our b squared of minus 2 minus 4 times our a of 5 times our c of k is greater than or equal to 0. So therefore we have 4 minus 20k is greater than or equal to 0. So now let's get rid of our number that doesn't have a pronumeral attached to it, so our 4. So we're going to subtract our 4 to both sides. So we get minus 20k is greater than or equal to negative 4. Then we're going to divide both sides by our negative 20. And remember, when we divide by negative 20, that we have to flip our sign. So our sign is now going to be k is less than or equal to our 1 over 5. Okay, So we're just trying to find out what values of k makes the quadratic equation have real roots. So the values of k that are less than or equal to 1/5 will make our equation have real roots. So that is our answer there. Moving on, we want to look at the discriminant and the parabola. So, as we know, the discriminant comes from a quadratic equation. Quadratic equations gives us parabolas. So the roots of quadratic equation, ax squared plus bx plus c equals 0, gives us the x-intercepts of the parabola. Okay, so our roots of our parabola are our x-intercepts. So if our discriminant is greater than 0, then we know that our equation has two real roots. So because it has two real roots, the parabola must have two x-intercepts. So we have our two x-intercepts. So here and here on our when a is greater than 0, and when a is less than 0, we have our two x-intercepts there. For our a is greater than 0, it just means our parabola is concave up. And when we have our a is less than 0, it just means our parabola is concave down. So then, if our discriminant is equal to 0, then the quadratic equation has one real root or two equal roots, like we know. So this means that our parabola has one x-intercept, okay? Excuse me. So our x-intercept is here and our x-intercept is here when our discriminant equals 0. So when a is greater than 0, it is concave up, and when a is less than 0, it's concave down, only hitting the x-axis once and having one x-intercept. And finally, if our discriminant is less than 0, then the quadratic equation has no real roots, like we know from doing the algebra. So that means that the parabola has no x-intercepts. So if you look at our graphs here, when a is greater than 0, our parabola does not hit the x-axis at any time, so it has no x-intercepts. And when a is less than 0 and our discriminant is less than 0, our parabola has no x-intercepts because it has no real roots. So let's have a look at some examples to do that with that. So what we want to do is we want to show that our parabola of our function fx equals x squared minus x minus 2 has two x-intercepts. So what we need to remember that our fx is the same as y equals our x squared minus our x minus 2, okay? And so we want to show that it has two x-intercepts. So when it has two x-intercepts, this means that we'll have two real roots. And when we have two real roots, it means that our discriminant is going to be greater than 0. So what we want to do is we want to find our discriminant, which is b squared minus 4ac. And we need to sub in our numbers. So we have our a equals 1, b equals -1, and c equals -2. So let's substitute them in. So we have our discriminant equals our b of -1 squared minus 4 times our a of 1 times our c of -2. So our discriminant equals -1 squared is just 1. Minus 4 times 1 times -2 is +8. So we have our discriminant equals 1 plus 8, which is 9. So our discriminant is greater than 0. So therefore, there are two real roots. So the parabola has two x-intercepts. And that is how we show that. Moving on to example 6, we want to show that for x squared minus 2x plus 4 is greater than 0 for all of x. So if this is greater than 0 for all of x, that means it's going to have no x-intercepts. And when it has no x-intercepts, it means that our function is going to be greater than 0, and that means our y is greater than 0, which is our range. And when we have no x-intercepts, we need to remember that we should have no real roots. So we want our discriminant to be less than 0. So let's solve that. So when we do that, we have our a equals 1, our b equals -2, and our c equals +4. So we have our discriminant equals b squared minus 4ac. So that means we should have, if we sub this in, our discriminant equals b, which is -2 squared, minus 4 times our a of 1 times our c of 4. So we get our discriminant equals 4 minus 16. So our discriminant equals -12. So our discriminant is less than 0, which says that we have no x-intercepts. So since our a is positive, so since a is greater than 0, we're given, and our discriminant is less than 0, our x squared minus 2x plus 4 is going to be greater than 0 for all real x. And that is the solution. So our because our a was greater than 0, that means our range was above the x-axis, and it will never hit the x-intercept, and it will always be above. So our x values will all be greater. So if you are following the Margaret Groves Maths in Focus textbook, if you are in following the advanced textbook, you would now do exercise 310. And if you are following the extension 1 textbook, you would do exercise 411. Have a lovely day.